Okay, good morning, students. So we are here today to revise atoms, isotopes, and ions. So this is a short revision lesson for the Sec 3 chapter on atomic structure, which is chapter 5, in case you have forgotten. So this is chapter 5, atomic structure. So in this chapter, we will be revising what is an atom, what does it contain, how do atoms form ions, what is the difference between atoms and ions, all right, and finally, we will end off by talking about isotopes. Okay, so three important words: atoms, ions, isotopes. All right, now before we begin, the way the Zoom consults will work is for you to go to your personal folder in the Chemistry OneNote, and under homework, you should find this document. Now, every lesson will have one document of questions that we will work on together. Through doing the questions, we will learn certain techniques that can be applied to solve different problems. Okay, so if you are ready, now we shall start doing a short summary before we start on the questions. So as mentioned, there are three important keywords: atoms, ions, isotopes. So we'll start with atoms. Now, I'm sure you have heard of the word atoms before. When you think of atoms, you think of something that is small, something that cannot be divided further. And that's why we say atoms are the most fundamental or the most basic building block of matter. What it means is that all the matter, all the chemical substances are made up of atoms. Whether you are looking at iron, sodium, oxygen, nitrogen, all your chemicals are made up of atoms. All right. And atoms contain subatomic particles. So the word particles, you are familiar, something small, right? Subatomic means inside an atom, what is there? Inside an atom, there are three particles: protons, electrons, and neutrons. So I'm sure you are familiar with these three: proton, electron, neutron. And they are different in terms of their relative charge and their relative mass. So these are the two properties where they differ from each other: relative charge and relative mass. Now, why use the word relative? The word relative means I'm comparing them against each other. So take, for example, the relative charge of a proton is +1. Protons are positively charged, whereas electrons are negatively charged in comparison to a proton. All right. Finally, neutrons are neutral. In this case, in this context, when we say neutral charge, means no charge. So neutrons are zero charge. Okay. Then we move on to the mass. Now, mass of a proton is 1. The relative mass of a proton is 1. Whereas that of an electron is 1 over 1840. Or 1 over 1836. You will see both versions. The reason is because 1840 is a rounded off number to 3 significant figures. All right. So immediately you can see, oh, this means that electrons is 1 over 1840. It's a fraction, right? Fractions are small, meaning electrons have a smaller mass than a proton. Electrons have a smaller mass. How many times smaller? It's 1,840 times smaller in mass than a proton. All right. So in case you didn't know, this means that electrons have very low mass. Okay, the fraction means electrons have very low mass compared to a proton. Okay, so you see, I use the word compared to. So that's the meaning of the word relative. Relative means comparing. Okay, finally, we have neutrons. Neutrons also have a relative mass of 1. What that means is that neutrons and protons have the same mass. Okay. So just based on this, you can easily predict already. Okay. So most of the mass is due to protons and neutrons. Most of the atom's mass will be due to just the protons and neutrons. How come electrons no, not included? Because electrons have a very, very low mass, small mass. All right. So their mass is negligible. It's not zero, but it's very small. Okay. And finally, we also need to know where are these subatomic particles located in the atom. So we'll just quickly go through that. The protons are located in the center of the atom called the nucleus. Electrons, however, are in electron shells. Okay, so electrons are not in the center. Electrons are in the shells around the nucleus. Finally, neutrons are also in the nucleus. So this summarizes what subatomic particles there are in an atom. All right. So let's take a few moments to take this down. And if you have finished taking this down, for those in the Zoom meeting, can you please give me a thumbs up so that I know you are done? Thank you. Okay, so at this juncture, we already know what's proton, electron, neutron. We know that they're different. They're not the same thing, right? They differ in terms of their relative charge, relative mass, as well as their location. Where are they found? Okay. The next step, of course, is how can we count how many protons, electrons, neutrons there are? So this one, I think you are already familiar with it. All right. Is the next concept of nucleon number and proton number. So take, for example, if I go to the periodic table and I find some element, this is an example, this is potassium, right? Potassium. The potassium chemical symbol is K. And when you go to the periodic table to find potassium, you will find two numbers associated with it, 39 and 19, right? So you need to know what these numbers mean, right? So quickly revision, the smaller number is called the proton or the atomic number. And this is the smaller of the two numbers. So the smaller number is the proton number, the atomic number. Okay, this is the same thing, proton number, atomic number. So what it means is that an atom of potassium has 19 protons. All right, because the smaller number is 19. Now, if it has 19 protons, it also has 19 electrons. And this is an important concept. For atoms, the proton number is the same, is equals to the electron number for atoms. All right, for atoms, later on we'll do ions in a short while, that's different. But for atoms, the proton number is equals to the electron number. Okay, now why is this the case? This is because atoms must be what we call electrically neutral. Okay, atoms are electrically neutral. What it means is that the number of positive protons is equal to the number of negative electrons. So just now we already saw, right? Protons are positive, electrons are negative. So if they are same in number, what it means is that the atom has no overall or net charge. the positive balance out the negative because they are the same in number. Okay? So you can imagine proton is plus. So you have 19 plus. Then electron is minus. So 19 minus. So the 19 plus and the 19 minus will balance each other out. Okay? That's why we say that there is no overall charge for an atom. Okay? Now with that, we have already counted how many protons and electrons. The last step, of course, is to count how many neutrons. And this is where, okay, you might have forgotten, the larger number is called the nucleon, or the mass number. This is always the larger number of the two. Okay, now what is nucleon? Nucleon means proton plus neutron. And this makes sense because we just said that protons and neutrons are found in the nucleus. So nucleon refers to the nucleus. How many things are inside the nucleus? Proton and neutron, right? So 39 means I in total have 39 protons plus neutron. So the sum of the two is 39. So how many neutrons will there specifically be? We take 39 minus away the proton, which is 19. So 39 minus 19, big minus small, give you 20. Okay? So that's how you work out a neutron. To work out a neutron, we take the larger number minus the smaller number. Okay, the quick revision. But for chemistry, we are very often interested only in the electrons. So if you have seen so far, for the next few lessons, we are going to talk about electron non-stop. Electrons are the most important because when a chemical reaction happens, it happens because the electrons are moving. It's either the electrons are being lost, gained, or shared. All right. So being able to count the electrons is crucial, important. Okay. So before we go on to electronic configuration, okay, please ensure you have copied down these notes. And when you're done, please give me a thumbs up so that I know you're done. Okay. Now we're going to move on to talk about electrons. So we know potassium has 19 electrons. So how are the electrons going to be located and arranged into shells? Can all 19 fit into one single shell of electrons? Okay, so if you remember, obviously, there are rules, right? There are rules. Okay, every shell holds a different maximum number of electrons. So what are the rules here? The rules are, first shell is maximum 2 electrons. So the very first electron shell, which is closest to the nucleus, only can hold 2 electrons, maximum. The second shell, maximum 8 electrons. The third shell, also usually maximum 8 electrons. So the first shell is 2, the second shell is maximum 8, third shell also usually maximum 8. So now potassium has 19 electrons, you know. So what is the electronic configuration of a potassium atom? When we ask you for the electronic configuration, we are asking you how are the electrons going to be arranged into shell. So how the 19 that you got from the periodic table going to be arranged into shell? We use this rule. First shell 2, because first shell is closest to the nucleus, is the smallest, it can only hold a maximum of 2 electrons. Second shell 8, because again, second shell, there's a rule, maximum only can fit 8. Now 2 plus 8 is 10. So I've written 10 electrons already as it is. But this thing has 19 electrons. Potassium has 19 electrons. So I've written 10. I must go to the third shell. Now third shell also maximum 8. right? So now you got to think and count. 2 plus 8 plus 8. 2, 8, 8 equals 18. So I've written 18 electrons as it is. However, how many electrons does potassium atom have? Potassium atom has 19 electrons. So 18, I'm still lacking 1. That 1 cannot go into the third shell. Third shell full already, maximum 8 electrons. So that last 1 electron must go into the fourth electron shell. And that is why the electronic configuration of a potassium atom is 2881. Okay? Now, this is writing the electronic configuration. You could, of course, draw it out as well. It's equally valid. So if we ask you to draw it out, it's quite straightforward. Put the symbol in the center, K. 2 in the first shell. 8 in the second shell. So this is the first shell, second shell. Third shell also 8. Finally, the last fourth shell, 1. 2881. Okay, so writing it versus drawing it. Okay, now actually this 2881, the electronic configuration tells you many things. All right. Now let's learn to unravel, decipher some of these bits of information that this electronic configuration tells you. So first and foremost, you notice there's 1 electron in the outer shell. The outer shell is called the valence shell. So it has 1 valence electron. 1 outer electron, 1 valence electron. So this is crucial. Because it has 1 valence electron, it is found in group number 1. If you look at the periodic table and find potassium, K, potassium is found in group 1 because it has 1 valence electron. Okay, all group 1 elements have 1 valence electron, meaning it has 1 electron in the outer shell. So because it's found in group 1, we can conclude the number of valence electrons or outer electrons determines the group. Okay, so group is determined by the number of valence electrons. Okay, next, the 2881. You notice when it says 2881, meaning got 4 shells. And you have drawn it as such, right? You have drawn 4 shells of electrons. Sure, not every shell, the 4th shell is not fully filled, but there is 4 shells. So because there are 4 shells, this means that it's in period 4 of the periodic table. Okay? So that means it go from left to right, periods from left to right, right? It's the 4th row, the 4th period of the periodic table. So we can conclude the number of electron shell determines the period. Okay? So this is crucial. This is commonly tested as an MCQ or even as a structured question. You need to know, oh, it's in group 1 because it has 1 valence electron. It's in period 4 because it has 4 shells of electrons. Okay, so this is crucial information obtained from the electronic configuration. So please take this down now, right? Now, so you have 2 pieces of information in there. Just based on writing the electronic configuration, you can work out the group, you can work out the period. The next important thing to work out from this 2881 is the chemical reaction that it will undergo. And this is what we call ions. 2881. The moment you hear 2881, it's like, is this going to be stable? If you look at it, it has one valence electron, only one electron in the fourth shell, which is the valence shell. This is clearly not stable. All atoms want to have a fully filled outer electron shell. But if you look at potassium 2881, the last outer shell is not fully filled. It only has one electron. So potassium clearly is not stable as an atom. Potassium has to lose one valence electron so that it becomes 288. So the key word here is lose. Potassium loses valence electron. So the electron loss is from the outer shell. So 2881, that one is lost, becomes 288, right? And now you look, okay, so now that I've lost all my electrons from the outer shell, I'm left with 288. 288 means it has 18 electrons. 2 plus 8 plus 8 is 18. However, just now we said, right, we lost electron. Do you lose other things? Do you also lose the proton? Based on this, you can clearly see only electrons are lost. Protons didn't change, and that is the case. In a chemical reaction, the proton will never change. The number of protons is not changed. So potassium, even after losing that one valence electron, still has 19 protons. The protons never changed. Okay? So what does this mean? This means that if I start totaling up, okay, proton is positive, electron is negative, 19 plus, 18 minus, right? Plus and minus. So if you look at it, oh, now it has more proton, less electron. Electron is less than proton. So this results in a positive ion. Positive ions have less electron than proton. All right? Less electron than proton. Okay, why? Because the positive ions are formed by loss of electrons. In order to form the ion, potassium had to lose one valence electron. So it lost one valence electron. So this is K plus. It's a positive ion. Okay? So now we are able to work out, oh, because the atom is 2881, so you lose the one valence electron. So it forms a positive potassium ion. Now, importantly, why lose one? The purpose of losing one is to achieve a fully filled outermost electron shell. So this is the purpose, the why, the reason why potassium must lose one valence electron. It is to achieve a fully filled outermost electron shell. And finally, to draw it out is quite straightforward. Once you can work out 288, so it goes from 2, 8, 8. Okay, now it's an ion, so you need to square bracket and put the charge outside. It's positively charged because it lost electrons. Okay, so this summarizes how you can make use of the periodic table to find the electrons. Then you can work out the electronic configuration, meaning how is it arranged into shell. And based on the electronic configuration, we can work out three things: the group, the period, as well as whether it will lose or gain valence electrons. Okay, so this is an introduction to ions already. Okay, so we can see that in an ion, the number of electron is not the same as the number of proton. So in this case, you have less electrons than protons. All right, so please take some time to take this down, ensure that you have taken it down and you understand what's going on. And if you have any questions, you can type it in the chat. I will respond to it. Okay, so you might want to write this as a K plus ion in case you didn't know this is called ion. It's not called an atom anymore. Okay, if you're done copying down, also give me a thumbs up so that I know you're done. Okay, good. Now, so I'm sure you can see, okay, so potassium lost one valence electron to form K plus ion. It's positive because it lost electron. So lose electron is positive ion formed. The purpose of doing this is to achieve a fully filled outermost electron shell. Now, not everything will lose valence electrons clearly. So something else. For example, if I started with chlorine, chlorine has 17 electrons, right? 17, so it's 2, 8, 7. Okay, I hope we can see. Chlorine has 17 electrons, so it's 2, 8, 7. First shell is always 2. Second shell, maximum 8. 2 plus 8 equals 10. That means you got 7 more. Can the 7 fit into the third shell? Yes. Because third shell maximum can hold 8. So if it's just 7, can still fit into the third shell. So chlorine, 2, 8, 7. Okay, so this is a chlorine. This is a chlorine atom. So atom means no charge. Whatever that you get from the periodic table, in this case, is 17 protons, 17 electrons. All right. Now, obviously, this again, you're going to ask yourself, is it stable? It's stable if the outer shell is fully filled. So we have to consider the outer shell always. In this case, it's the third shell where the 7 valence electrons are. Is 7 a fully filled third electron shell? The answer, of course, is no. We know the third shell can hold maximum 8. So 7 is not 8. 7 is not fully filled. So we know that this is not stable. Chlorine atoms are not stable because they do not have a fully filled outer electron shell. So how do you make it fully filled? Does it lose 7? Or is there an other way? Which is, if I to make fully filled is 8 electron, right? Instead of losing 7, why don't I just gain 1 more? So chlorine has 7 valence electrons in the atom. To make 8, I just have to gain 1 more. If I gain 1 more, it becomes 2, 8, 8. Right? We already know this. So now, 2, 8, 8. 2 plus 8 plus 8 is 18. I have 18 electrons in the ion of chlorine. All right, and that makes sense. At first it's 2, 8, 7. I gain 1, become 2, 8, 8. 17, I gain 1, became 18. But did the protons change? We must know and remember the protons don't change. That means whatever is from the periodic table, the proton number will never change. Okay, and this is a concept. Protons don't change. So it still has 17 protons like before. Protons are never lost, never gained during a chemical reaction. So it still has 17 protons, but now it gained 1 electron. So proton is plus, electron is minus. So now easy to work out, right? Once you know that it's 17 proton, 18 electron, you can now work out the overall charge. The overall charge is not 0. It has more electrons, right? So this will be negative ion. Negative ion is where electron is more than the proton. So you got more electron than proton. And this makes perfect sense because negative ions are formed by gain of electrons. You gained electrons. Chlorine gained 1 valence electron to form the negative ion. So this is the Cl minus ion, which is called chloride. Chloride ion. Okay, so it's not chlorine anymore. Chlorine is the atom itself. All right, chloride is the ion, the negative ion. Okay, so you can also draw this 288, quite easy, right? Okay, 2, 8. Now, this is where you need to be slightly careful. It gained a valence electron, so you must use a different symbol for the electron gained. Then you must square bracket and put the negative charge, the charge outside it. Just like what we did for K plus just now, Cl minus, the minus charge must be indicated. Okay, so this is how positive and negative ions are formed. Okay. So we have seen positive ions, they have lost electrons, so they have less electrons. Negative ions are formed by gaining electrons, so they have more electrons. Okay. So once you have finished copying this down and you understand it, can you give me a thumbs up so I know that I can move on? Now, instead of going on to isotopes directly, I'm actually going to go through one of the questions that you see inside this document first, which is a common prelims questions that's asked. Okay, but let's go to the question only when you have finished copying. So once you have finished copying, thumbs up so that I know that you're done. Okay, now, so the question can be found in your OneNote, as I mentioned just now. It's called JH1. Okay, this document. I hope you can find it. It's under your personal folder under homework. All right. Now, if you read this question, this is actually a prelims question from another school. All right. Immediately you realize it's probably something to do with atoms or ions. It says that atoms or ions, right? You are given the number of protons, number of neutron, number of electron. You are given 3 different pieces of information. The question is, where do you start? Now, whenever you are given a question with number of protons, electron, neutron, whenever you are given this kind of data, you always start from the proton. Okay, start from the proton number. The proton number tells you what is the element's name. How? We know the proton number is the smaller number found in the periodic table for that element. So based on the proton number, I can identify the element. For example, I see that particle A has 6 protons. So I look for proton number 6. I look in the periodic table. Which is the element that has smaller number, proton number 6? And I find out that it's carbon. Proton number 6 belongs to carbon. So this is where the periodic table comes in. You need to go to the periodic table. This is from the periodic table. You cannot do this from memory. You need to go to the periodic table and search. Proton number 6 means carbon. Just like 12. 12 means magnesium. And so on and so forth. So you continue searching the periodic table for the names of the elements just based on the proton number. The proton number allows you to identify the element. Okay? Then you go 13. 13 is what? Okay, 13, you look in the periodic table. Should be after 12, right? 13 is after 12. So what's the element after magnesium? Aluminium. Okay, so now for those in the Zoom meeting, I hope you have a periodic table in front of you. If you don't, you might want to go and quickly find one, because can you try to identify what is D, E, and F yourselves? Okay, can I give you just about 1 minute to go and find out what is D, E, and F just based on the proton number? And once you're done, can you please just type in the chat to me, okay, select to me, all right, what is D, E, and F? Okay, so those in the Zoom meeting must type in the chat, what is D, what is E, what is F? Okay. Okay, so I think you have seen your friend type it. All right. So quickly, 8 protons. Proton number 8 is oxygen. All right. Now, one quick tip is that elements in the periodic table are arranged according to the proton number. So 8 protons means the 8th element. So just count 1, 2, 3, 4, 5, 6, 7, 8. That's oxygen. Then after that, sodium is 11. And finally, 12, we've just seen it just now, is magnesium. All right. Now, this is important information, because if you look at it, this once you have identified the element's name, you have won like 65% of the battle already, you know, because you roughly know, oh, so this is carbon. Carbon is a non-metal. Magnesium is a metal. At least you know, right, that, oh, you know, it's a metal or non-metal. Next, if you look at the 6 particles, A to F, 2 of them are the same element. B and F are both magnesium, right? So immediately you know that, oh, this is what you have learned as isotopes. Isotopes are atoms of the same element with the same number of proton. So B has 12 proton. F also has 12 proton. They have the same number of protons. That's why they are both magnesium. But the only difference is the number of neutrons. So B and F are isotopes, which is the answer for the last part of this question. So you can identify the isotopes so easily just by knowing that they are the same element, same proton number, but different number of neutrons. All right. So isotopes we'll go through again next lesson, but important to know isotopes, they must be atoms of the same element. So just by identifying the element's name, you already know, oh, it's both magnesium. With the same number of protons. So they both have 12 protons, hence they are both magnesium, but different number of neutron. Okay, so B and F are your isotopes in this case. Next, once you know the element's name, not only can you identify which ones are isotopes of each other, based on the chemical name, you can even find out what group it's in, right? So if you look at part D, which particle can be found in group 4? IV is 4. Which particles in group 4? Look at the name. Which one is group 4 element? You just go to the periodic table, search group 4, which one? The answer will be carbon. Carbon is in group 4. Therefore, particle A. Particle A is carbon. Therefore, it's from group 4. So this is how you can get most of the marks, just on the basis of understanding what element it is. All right. Now, so this is the first thing to do. Whenever you are given such a question with numbers of protons, neutron, electron, you start with proton number. That's the first step. From proton number, go to periodic table, find the name of the element. Now let's go to the second step. The second step is to look at the electrons. Specifically, you must know, is it an atom or ion? Okay, so let me just zoom in a little bit. We look at the electrons. The electrons will tell you whether it's an atom or ion. How to know? Well, if you recall just now, atoms, the proton equals to the electron. That means the proton number is the same as the electron number. So like A has 6 protons, 6 electrons. So it's an atom. So A is a carbon atom. B, 12 proton, 12 electron also. Atom. Magnesium atom. Then you come to C. Immediately you see something odd, right? It has 13 protons, but only 10 electrons. It has less electron. Less electron means the charge is no longer 0. Less electron means it's no longer no charge, no longer an atom. Less electron means it's positive ion. Because positive ions, like potassium just now, were formed by losing electron. Losing electron, you have less electron. How many less? How many less? In this case, 3 less. It has 10 electron only as compared to 13 protons. So it's 3 less electrons. So it's 3 plus ion. So this is the aluminium ion with a 3 plus charge. Why 3 plus? Because it has 3 fewer electrons than protons. Next, from C, we go to D. Again, you apply the same step. You look at the electrons versus the protons. 8 protons, 10 electrons. Now this is the reverse, right? If you look at it, just now was less electron, but now 10 electrons. It's more than the protons. It's 2 more. It gained 2, meaning this is also an ion and it's 2 minus charge because it has 2 more electrons. It gained 2 electrons to form this ion. All right. Finally, sodium and magnesium, E and F. We also use the same principle. Look at the electron and compare it with the proton. For E, it has 11 electron, 11 protons. So same. If the two are the same in number, it's an atom. So it's a sodium atom. Finally, F, 12 proton, same as 12 electron. So it's also an atom. Okay, so you need to do these 2 simple steps whenever you see such a question to ensure that you get the correct answer. Find the element's name from the number of protons, then find out if it's an atom or ion based on comparing the number of electrons and the number of protons. Okay, and with that, I think it's very straightforward, right? Once you have written out the atom or ion, once you have written out the charge as well, the answer to the rest of the questions is obvious. Part C, for example, which particle is an ion with a negative charge? If you look at the list that you've just written, which one is an ion and which one is negative charge? The answer is oxygen ion, right? The oxide ion, which is D. This one has a 2 minus charge, so it's negative. Okay, finally, all right, let's look at the last 2 parts. Which one is an atom of atomic number 12? Now, atomic number is also known as proton number. So which one has proton number 12? That's what they're asking you. There are 2 answers to this, right? Both B and F have proton number 12. The number of protons is 12. Therefore, the atomic number is 12. Which one is an atom with nucleon number 14? Nucleon number is proton plus neutron. That means you add up the P and the N equals 14. So you go through the list. Which one adds up? The P and the N add together is 14. For those in the Zoom room, what is the answer to part B? Can you type in the chat? Okay, let's think through part B. What's the answer to part B? Is it A, B, C, D, E, or F? Nucleon number is 14. So it's P plus N equals 14. So is it particle C? Particle C has 14 neutrons, So the nucleon number is not 14. The nucleon number of particle C is 13 plus 14, which is 27. All right. So remember, nucleon number means you must take the proton plus the neutron. So which one will have nucleon number 14? So the answer is P plus N equals to 14. So the answer is A, right? 6 plus 8 gives you 14. All right. So this is an important trick question. Many students will think that, oh, no, just go straight for the one that has 14 inside. But you must be careful because you must remember the nucleon number is P plus N, proton plus neutron. All right. So it's particle A. Particle A has 6 protons, 8 neutrons. So 6 plus 8 gives you 14. Okay. Okay, so I hope you have seen this is a 5-mark question, and 5 marks is a lot of marks. If you think about the fact that your structured questions, you only have 30 marks of structured questions, 5 marks is 1/6 of your mark already. That's about 16% of your marks, okay, for the structured paper. All right. So how do you do such a question? You need to identify the element's name. After that, you use the electrons to work out, is it an atom or ion? All right. So today we have summarized what is inside an atom. We have summarized what is proton number and nucleon number. Hopefully we remember nucleon number is proton plus neutron, P plus N. All right. We have also summarized how do I use the number of electrons to write the electronic configuration. So just now we wrote 2881. Okay, that's an electronic configuration of a potassium atom, right? And based on the electronic configuration, we can work out a few pieces of information, such as the group, the period, as well as whether it will form ions that are positive or whether it will form ions that are negative. All right, so you have done quite a lot today, just based on what you've copied down. The key thing to do now is to not just copy down and leave it at one side. You need to internalize whatever you've copied down, particularly the portion on electronic configuration, as well as the loss and gain of valence electrons. You need to revise this. All right. This will help you a lot in understanding virtually every single topic that follows next. Okay, so please make it a point to revise, reread what you have copied down today. Now, if you have some time, can I please encourage you, in this JH1 document, we have done question 1 together using these 2 steps. All right, 2 simple steps. Similar questions are question 2, as well as question 3, all right, and 4. Can I please recommend that you try out at least questions 2 and question 3? All right. This can be found in your OneNote under your personal folder homework. All right. Entitled JH1. So the next session, which will be on Friday at the same time at 9:30, we will be going through the remainder of the questions, revising isotopes as well, before we revise ions once more and go through ionic compounds. All right. So I hope this lesson has given you some chance to revise atomic structure, because this is crucial for you to understand other things. Okay. So if you have any questions, please reach out to me via WhatsApp so that I can answer you. We should be trying our best to revise for chemistry. Okay. So thank you. Let me just stop the recording now.